Hello everyone, welcome to YX-ElevatorTechnology Elevator Group Technology live stream. I'm your guest host, Aurea. Today, we will spend 17 to 16 minutes explaining the troubleshooting method for special faults in the Monarch NICE3000new system and answering questions about various elevator brands you may encounter. Please share your most challenging technical issues or faults in the chat. We will respond directly in the chat or select representative questions for detailed answering in Part 4. Participants who actively engage during the live stream will receive exclusive component gift after the live shooting. Today, our training content mainly have 4 parts. The Part 1, Working Principle of the Inverter Main Circuit. Part 2, Working Principle of the Traction Machine. Part 3, Parameters Setting of the Special Faults. Part 4, Troubleshooting Peculiar Elevator Faults. Today's training relies on our self-built technical laboratory equipment, the Monarch NICE3000new series experimental platform, as well as the experimental platforms of Otis, KONE, Schindler, Mitsubishi, and Shanghai Mitsubishi. By restoring the real elevator system with 1-to-1 high precision, it fully supports application scenarios such as product display, function demonstration, and performance testing. Now, please welcome our speaker, Yuri. He will kick off today's main course content with explanation and demonstration.
Hello.
那我现在直接说了啊。Okay, now let's get into the first part, the working principle of the inverter main circuit. Inverter drive is a controller that regulates motor operation. It converts a fixed frequency alternating current power supply, 50 Hz in China, into an alternating current power supply with adjustable frequency and voltage, thereby controlling the motor rotational speed. 好，到这个图上了。发挥的时候别说太多啊。Okay, let's see the drawing in the board. Now let's talk about the first part of the inverter. Is the 继续。
然后我们图中的6个二极管组成了我们的3相桥市场轴。
In the drawing, we can see rectifier diodes is made of 6 to make our rectifier section.
是将我们的3相输入电源经过整流后变成平滑的直流电源。
It's used our 3 input power after the rectifier section to become our DC volts.
我们3相整流的输入部分是由6个二极管组成的。
Three-phase rectifier section input process is made of 6 rectifier diodes.
我们的第1、第2、第3是我们的上桥，上桥。
D1, D2, D3 is the full wave circuits of the upper bridge.
第2、第4、第6是我们的下桥。
While 2, 4, 6 denotes the rectifier circuit for the lower bridge arm of RST. 继续。
然后最后这儿里面我们可以区分一个半波整流和一个全波整流。
At this part, we can distinguish a full wave circuit and a half wave circuit.
我们的半波整流一般只是一个二极管，比如我们的单向220伏。
Our half wave circuit is usually just one deltas, just such as our 220 volts.
它整流后的直流电压一般在0.45到0.55之间。
The voltage after the rectifier section usually as 0.45 to 0.55.
电压大约在99伏到120。
The volt is around at 99 to 120.
然后我们的220伏的全波整流是用了一个上桥和下桥的二极管，只用了2个。
Our 220 volts full wave circuit is use our D1 and or D2 two deltas.
它整流后的电压大约是输入电压的0.9。
The voltage after the rectifier section, the voltage is around the 0.9, which is 198 volts.
大约198。
It's around 198 volts.
我们的三向调制整流是使用了6个二极管。
Our three-phase rectifier section use like 6 deltas.
它的整流后的电压大约是380伏的1.35倍。
After the voltage after rectifier section, the voltage around like
1.35倍。
Okay, 1.35 times is around like 513 volts.
因为现在我们讲一下这个三向全波调制整流。
Now we are talking about the three-phase full wave circuit.
因为三向整流后是要经过我们的电容充电。
再说一遍。
三向整流后是要经过电容的一个充电，给电容一个充电。
The rectifier section of our three-phase circuit will need our capacitor give energy.
所以经过电容充电的电压约等于380伏的1.414倍，约等于537伏。
The voltage after it is around at 1.414 times. It's around at 537 voltage.
我们三向整流过程中，上桥第一、第二、第三，哪个电压高哪个导通。
The 1, 3, 5 deltas, the one with the higher volts conducts.
下桥2、4、6，哪个电压低哪个导通。
At the lower bridge 2, 4, 6, the one with the lower voltage conducts.
我们的 RST 输入三向电源相位相差120度。
RST three-phase input power supply with phases spaced 120 angle apart.
导通总是在相位最高的一个相位最低的一个。
Conduction in rectifier deltas always occurred as the deltas with the highest and the lowest phases.
然后在这里说一下我们这个相位相差120度是怎么来的。
Okay, now let's see how this 120 angles comes.
因为我们的发电机也是按我们的氢进行接法接的，它的角度相差都是100。
We can see like this triangle. It is made of RST three angles, and each angle is like 120 angle.
所以我们的 R 到这个 N 中心点是一个220度。
So the middle place from R to N is around 220 volts.
S 和 T 到这个中心点都是220。
The middle parts from ST to T is also 220 volts.
如果在我们的等腰三角形上取一个中，
If we made it at this isosceles triangle, made a middle part,
所以我们的电压是30度。
so this part will be like 30 angles, 60 angles, and 90 angles.
所以这一块电压是110。
So this part voltage will be like 110 volts.
根据直角三角形的定律是2比1比0号3。
According to the principle of right angles triangles, so this three lines is like 2 to 1 to the square root of 3.
所以我们算 S 和 T 之间的电压是220伏乘以个0号3，约等于一个380。
So let's count the voltage from I to T is around 220 volts times the square root of 3 will equals like 380 volts.
我们的根号3就是1.732。
The square root of 3 is around like 1.732.
所以我们的相位相差120度，正好是我们的一个380度的。
So like the phase space 120 angle apart is just like our voltage 380 volts.
我们在3项整流过程中，大概可以分为6个周期。
One large cycle is divided into 6 segments.
然后在每一段由一个象限对负载进行供电。
Each quadrant will use a load to give the power.
在一个大周期中，每个二极管都有1/3的时间导开。
In a whole cycle, every deltas have 1/3 times conducted angles.
所以我们从这里可以看到，
Also at this part, we can see
我们这360度刚好完成了一个大周期。
the 360 angles just finish one large cycle.
所以我们在0到60度之间，我们的 R 项电位最高，
From 0
电位最低。
to 60 degrees, phase C reach its peaks, while phase B is at its lowest.
所以我们的电流是通过 R 项流入，经过我们的直流母线，从我们的 T 项流出。
So our current is from R and through the DC bus circuit to T output.
在60到120度之间，
At 60 to 120 angles,
60到100度是我们的 S 最高，
the S get its
T 最
peaks
低。
as the T get its lowest.
所以我们的电流是通过 S 第3流入。
So our current is from our SD3 through the DC
从
bus
第6流出，
circuit to our D6 output.
然后在120到180度之间，
From the 120 to 118 angles. 继续。 120的180。
我们的 S 最高
The S get its peaks,
，R 最低，
while the R get its lowest place.
所以我们电流是从 S 第3流入，从第2流出。
So our power is from D3 to D6, T2.
然后以此类推，对，
The same meaning.
这6个二极管来回的导通，
The 6 deltas conduct each other.
在一个360度完成6次的一个整流。
A sine wave undergoes 6 periodic pulsations.
刚好完成了一个3项整流过程。
With the full 360-degree cycle completing one complete phase transition of the 3-phase sine wave.
所以我们有时候测量这个二极管是如何来测的。
So, therefore, when measuring rectifier deltas,
去电视上去测试一下。
we can sometimes use a delta test function on a multimeter, which involves test the following pairs.
然后我们将我们的放力打入二极管这个。
We can get the test tube get into our deltas.
-我们先测量我们的1、D3、D5的上桥电路。
We can measure the D1, D3, D5, the upper current circuit.
将我们的表笔放到正极。
Use the pen as a positive part. And another
然后
pen.
测量它管压降3的压降。
So here we can see the rectifier diode's voltage drop range from 0.3.
然后它和 R、S 和 T 都有这个。
R, S, T, all of them have 0.3.
如果我们将表笔反过来，
If we change the pen to different power place,
测量出来是无穷大的。
the result will be the.
然后我们测量下桥D2、D4、D6的二极管管压降。
Now let's count the D2, D4, and D6.
将我们的黑表笔接入直流线的负极。
Use a black pen to our DC bus power negative
然后测量我们的 R 是无穷大的。
to point
S 无
our
穷大
R,
T 无穷大。
to point our R, S, T, all the increasing.
然后我们能将红表笔接入直流线的负极。
We use the right pen into the DC bus power negative.
然后黑表笔分别测 R、S、T。
The black pen to test the R, S, T.
只有一个0.3的压降。
Only have one 0.3 voltage drop range.
下面我们用我们这个整流3级整流模块可以测一下。
Now we use our rectifier module to test.
我们这个整流模块是一个1600伏60安的模块。
We can see the parameter of our module.
然后这是我们的输入 RST 3项电源。
This is our input 3 RST 3-phase.
这2个正负是我们直流母线整流后直流母线的电压正负极。
These two are the positive and negative of our DC bus power.
所以我们测量上桥比还是一样的，推表比放入母线的正极，红表比分别测 RST 的压降。
As shown, we put the pen to the corresponding place to test the voltage drop range.
交换表比是无穷大。
Exchange the pen, it is become the voltage, will become the infinity.
我们的红表比放入母线的负极，
The right pen
分别
put
测
on the negative
RST。
to and use black pen to test RST. All of them will be like
交换表比无穷
0.4.
大。这是
Yeah. Exchange the pen, it will become to infinity again.
然后就是我们的正极测的是我们的上桥比 D1、D3、D5， 负极测的是下桥比 D2、D4、D6。
The positive pen is to test the D1, D3, and D5, and the black pen is to test our bottom place D4, D2, and D4, D6.
所以我们这 P 正测的就是我们的上二极管。
So P positive is to check our upper deltas,
然后我们的 N 极就是我们的负极，测的是下。
and the N is our negative to test our bottom deltas.
然后下来就到我们的一个经过整流后，就到我们的一个直流母线电压 DC bus。
Then to the DC bus, where the AC current is rectified into a flattered.
然后我们的直流母线是经过我们二极管整流后，经过电容充电得到了一个平滑的直流电。
Where the AC current is rectified into a flattered smooth DC voltage.
经过电容充电后，它的电压会达到一个尖峰值，大约537伏。
After the energy is given, this DC voltage is typically 1.414 times the input power supply.
一般我们直流母线会有2组电容，对，
Meaning 380 times 1.414 yields approximately 537 volts. Typically, a DC bus incorporates two capacitor connects in serials. 两个电容串联，
是吧？
从两个电
然后
容。
使用2个内压值高的电容串联进行分压。
These high voltage rated capacitors are used for voltage division, producing equal voltages across each phase. 当遇到
然后我们平常遇到的一个故障就是我们的母线过压。
When encounter a DC bus overvoltage issue at half the rated voltage, the cause is largely unrelated to the input power supply.
我们的母线过压这个故障一般是与输入电源关系不是很大的。
Yeah, the cause is not very large, unrelated to.
大部分是我们电机在发电的过程中，经过整流二极管给电容充电，导致直流母线电压直接升高。
The energy dissipation until a unit forced to activate, causing the DC bus voltage to raise and prolonging declaration time.
这种情况一般是我们的后能制动单元不工作，或者直流母线电压直接升高。
This time usually like our braking unit not working,
还有是我们的制动电阻损坏。
or also make our brake units breaks, resistor malfunctions, preventing the IGBT from functioning.
还有一种情况是我们的电机在发电过程中导致制动电阻的消耗不及时。
There is another reason is about like our energy give is untiming.
这种情况可以延长我们电机的一个加减速时间和减小加减速速度。
At this function, we can try to belonging our increase or decrease speed time.
然后经过我们直流母线，经过电容充电得到一个平滑的直流母线，接下来就到我们的逆变部分。
Next, we can get into our frequency IGBT part.
我们的逆变部分是由一个 IGBT 和二极管组成的，它叫绝缘栅双极晶体管。
Our frequency is made of the IGBT insulated gate bipolar transistor.
然后我们 IGBT 有一个 G 级、C
IGBT
级、E 级。G 级是我们的开关。
IGBT is have our G, C, and E. G is our MOSFET gate as well as the switch. So C is our transistor collector and E is our emitter. G is our control switch, C is our collector input, and E is our emitter output.
我们的每一个 IGBT 都会并联一个气流二极管。
Each IGBT will connect our diodes.
是为我们电机发电过程中给直流母线供电提供通道。
Is to give our space to give the power to the DC bus power.
然后我们的 IGBT 是给一个高电平 IGBT 导通，给一个低电平 IGBT 关闭。
Give the high frequency is to conduct, and give a low, it will be stopped.
并且我们的逆变模块的供电是由我们的直流母线供电。
Our frequency model is be giving the power from our DC bus power.
然后 IGBT 的上桥和下桥不能同时导。
The IGBT's upper bridge and the bottom bridge cannot be conducted at the same time.
如果上桥和下桥同时导通，我们的直流母线会直接短路的。
The upper and lower bridge of an IGBT cannot be turned on simultaneously, as this will cause a DC short circuit.
然后我们逆变工作中是由我们的 CPU 程序发送6路 PWM 脉冲宽度调制的，来控制 IGBT 的开入导通和截止。
During operation, 6 IGBT are controlled. The turn-on sequence of the IGBTs ensure the UVW, their 3-phase volts are 1 to 0 degrees apart. Here, let's count the 135 and 246 upper and bottom circuit.
例如，我们的直流母线电压经过我们这个 V1，从我们的 V1进入，然后经过我们的电机从 V4流出。
Such as our DC bus power from our VE and through the model and go out from the V4.
这样我们的电机就有电流通过，然后电机就会旋转。
The model will have the current across too, and the model will rotate.
这样来回不停的导通和关断我们的 IGBT， 我们的电机就会一直在旋转。
Keep doing it, and the model will keep rotating.
然后下来到我们的电机部分。
Now let's get to the motor part.
我们的电机运行分为4个象限。
Our working principle of the traction machine is divided into 4 quadrants: 1, 2, 3, 4.
我们的第一象限是我们的驱动供电的正卷。
The quadrant 1 is for a traction machine rotating clockwise.
我们的第三象限是驱动供电的反转。
The quadrant 3 is for a traction machine rotating counterclockwise.
第二象限是我们的一个驱动，在没有电源驱动的情况下，电机的一个惯性和制动。
Quadrant 2 is for a traction machine rotating clockwise with counterforce.
第四象限是电机在反转的一个发电过程。
The quadrant 4 is for traction machine rotating counterclockwise with driving force.
所以我们的1、3象限是我们电力驱动的一个正反转。
So our quadrant 1 and quadrant 3 is our motor drive.
我们的第2和第4象限是在电机的一个惯性制动减速过程中，电机处于发电状态。
At the quadrant 2 and the quadrant 4 is at a great speed time, and the motor will be like at an energetic given time.
然后电机发的电会经过我们这二极管，将给直流母线充电。
The energy from the motor will through our deltas to give the DC path power.
然后我们的直流母线将充满电之后，它需要将多余的电能消耗掉。
The DC bus power, when it get enough energy, it will need to get the excess electrical energy to be converted.
在以前的2象限变频器中，是将我们的多余的电通过我们的变频器的制动单元和制动电路，将电能转换为热能消耗掉。
In our old quadrant 2 model working process, we'll use the brake unit or the resistor to get the excess electrical energy is converted into heat energy and dissipated.
然后在我们现在的4象限变频器中，我们莫纳克有一款 YX-ElevatorTechnology。
In our quadrant 4 part, our inverter have a AFE version.
这可以实现我们的4象限控制变频器。
This can realize our quadrant 4 frequency converter. Which can get the energy recover power supply.
在我们的4象限变频器中，当我们的电机发的电到我们的直流母线充满电之后，多余的电，它会在前端也使用一个逆电单元。
We will use at the first part use a frequency unit, and when the motor is getting to the P positive to N.
它也是使用我们的 CPU 控制，将我们的 IGBT 开关关断截止，来使我们的直流电变成与电网相同的交流电。
It's also use our CPU control to make our circuit to become our DC AC power.
然后然后转成的交流电将与电网的频率、电压是一样的，然后可以实现节能的效果。
And this way we can realize the energy recovery and power supply. The elevator will save a lot of power.
咱下来就到我们的一个电机。
Okay, now let's get to the model place.
我们的电机分为一个星形接法和一个三角形接法。
Our model is divided into the star connection and the delta connection.
我们的星形接法由这个 U1 到 U2。
Our star connection, as the shown in the drawing, from the UE to U2.
这是一个相电压。
This is a phase current.
然后 V1 到 V2 是一项绕度，也是一个相电压。
the V1 to V2 is also phase current.
让 W1 到 W2 也是一个一项肉组的电压。
From W1 to W2 is also a phase current.
然后我们的星型接法在这个地方，它实现了一个中心点 N。
Our star connection at this part realized a middle place called N.
所以在这里，我们首先要了解一个相电压和线电压。相电压是我们的火线与零线之间的电压。
继续说完。
线电压是我们的火线与火线之间。
So now let's distinguish between the phase voltage and line voltage of the traction machine. Line voltage is the line wear and line wear, and phase voltage is line wear and neutral wear.
所以我们380伏的星型接法的电引机每项绕组之间，它的电压是220伏。
So at the phase voltage of each winding in the 380 volts traction machine is 220 volts using a star connection. Okay. The voltage of each winding in a 380 volts traction machine equals 380 volts, with phase volts equals to line volts using a delta connection. The voltage borne by each phase winding in the star connection equals 1/3 root of the power supply voltage, approximately 0.577 times. Therefore, the voltage across each phase winding of a star connected traction motor is approximately 220 voltage. Connecting use U2, V2, and W2 to form a common neutral point N. 这块太多，有缺点。
这个不多，这儿就结束了。
行。Advantage of star connection. In a star connection, the ends of the winding are connected together, while the beginning are connected to the power source. Each phase winding experiences a lower operating voltage, resulting in reduced starting current and lower torque. This ensures smooth operation and lower in the insulation grades requirement for the windings, thereby enhance the reliability and service life of the traction machine. The disadvantages of low starting torque, unable to start under heavy load. Wow.
所以我们的星型接法通常就是将 U1、U2、V2、W2 连接起来。
So our star connection is usually like connect to the U2, V2, and W2.
所以我们的星型是横向连接。
The star connection is connected like this.
所以我们的星型接法平常是如何去测的？
How to count our star connection?
我们可以去单独去测我们的 U、V、U、V、U、W、V、W 之间的电阻。
We can count the resistor of the U to V, U to W, and V to W separately.
如果我们拆掉这个连接片，拆掉这个连接片的话，我们就要测 U1 到 U2、V1 到 V2、W1 到 W2 之间的电阻。
If we get the part of this part, we need to count the resistor from V1 to U2, and U1 to V2, and W1 to W2.
那下来说一下我们的三角连接。
Now let's talk about the delta connection.
我们的三角连接法是首尾相连的。
Our delta connection is the winding are connected end to end.
所以我们三角形的接法的每一项绕走之间380伏的电机和每一项之间的绕走电压也是380伏。
So with the line voltage applied directly to each phase winding, when the line voltage is 380 volts, the phase voltage of each winding is also 380 volts.
所以我们三角形测的话和能平衡测法是一样的。
The testing the way for the delta connection is the same with the star connection.
所以我们三角形的连接方式是 U1 连接 W2，U2 连接 V1，W1 连接 V2，它是竖向连接的。
So the delta connection, the text way is like U1 to W2, U2 to V1, W1 to V2.
所以我们如果不拆这个连接片的话，能测出来的电阻也是 U1 到 U2，V1 到 V2 之间 ，U1 到 U2，V1 到 V2，W1 到 W2。
So if we don't get apart this resistor, our text also from the U2 to V1 and U1 to W2 and W1 to V2.
这个测出来是我们的一个总绕阻，因为我们的绕阻从 U1 到 U2 这个连接的，经过这里还有一个，所以测出来是两边的。
And this way, we can count the winding of the total connected.
还有一种就是直接测我们的 U、V、W 之间的电阻。
Another way is to directly count the resistor between the U, V, W. The advantage of the delta connection, the windings are connected end to end with the line voltage applied directly to each phase winding. When the line voltage is 380 volts, the phase voltage of each winding is also 380 volts. The line current is 1.732 times the phase current, or approximately the square root of the 3 times. High starting torque, since each phase winding directly bears 380 volts voltage. The starting torque is substantial, resulting in high output power. The same traction machine can deliver approximately 1.5 times greater power in delta configuration than in star configuration. The rated power of the traction machine is typically specified for delta connection output. Also, there also have the disadvantages. The starting current can reach several times the rate current, causing significant impact on the power grid. 测，继续测。没有，他漏了一个。现在在测，来得及。
也就是说，我们这里刚好有一个 IGBT， 我们可以顺便测一下。
Okay, now we happen to have an IGBT model. We can test it on site.
因为我们 IGBT 里边也会并联两个二极管。
The IGBT is also connected to deltas.
所以我们测量我们的 IGBT，
So when we So when we test our IGBT, it also have a rectifier voltage drop.
如果反过来
If exchanged, it will be infinite.
然后第二个管角这也有一个二极管的转压降。
At this part, there will also have a deltas voltage drop across a tube.
然后反过来也是无穷大。
Exchanged, it will be also like infinity.
这样只能测量我们的一个二极管的好坏，但是我们的开关好坏需要我们一个指针万用表。
The functional of this part, we can only test the rectified deltas, but if the switch, we will need another way.
我们将我们的档位打到 10K 档，电阻档打到 10K。
We can set the level to 10 key.
然后将我们的黑表笔打到 C1，红表笔打到 C211。
Put the black pen to the C1 and right pen to the C2.
我们可以给一个开关转接一下。
We can give a circuit to one of the switch.
它这个指针到这里还能保持住，证明我们这一路是好的，我们 D1这一路是好的。
With the pin to arrived at this parameter, it can prove our G1 is good.
然后我们可以去关掉它，给它一个低电，就可以关掉。
Give it a low power, we can close it.
然后我们来测量我们的 G2。
Now let's count our G2. The same way, put the
我们第二
pen,
一个，
give a circuit for the G2.
然后它打开并能保持住。
When it opens, and it can maintain at this parameter.
我们再给它一个短接，负极短接，把它关掉。
Give it a negative power and close it.
这就是我们 IGBT 的，给个正电压，开关导通，负电压，开关截止。
It is like IGBT. When you give it the positive power, the switch conduct, and give a negative power, the switch close. Stopped.
下来我们到我们第三部分，一些变频器的一些特殊参数。
Okay, now let's arrive our third part. It's about the parameter setting for special faults of our inverter. Okay, now let's see the test tool.
然后我们就是我们这个密码测量。
First, we need to get into the decode menu.
然后输入密码1430。
Set the FF to the 01430.
然后我们的 FF01是一个变频器一体机型号的一个设置。
The FF01 is a settled value for our integrate elevator controller.
一般是根据我们这个条码去设置。
Usually we set according to the white code. Okay. So let's see. If you need NICE LABC4002, we will set FF01 at 10. If NICE LC4003, we set 11. LC4005, we set 12. 7 and 2004, we set 13. And 4011 and 2005, we set 14. As the same meaning, we can see the right part. 4015 and 2007, we set FF01 at the 15 part. And the 4018F version and 2011, we set 16. 4022F and 2015, we set 17. And 4030F and 2018, we set 18. 4037F and 2022, we set 19.
然后下一个是我们的一个 FF08。
Okay, now let's see the FF08 setting value.
一般情况下，如果我们的电源没有问题，报直流母线过压，可以检查一下这个直流母线的系数。
Usually, if our DC bus power is no problem, we can use this set value to test the bus voltage correction factor.
标准是设成100%。
The standard version is to set the 100%.
我们的 FF-10是我们调整一个输出向序。
The FF10 is to adjust output phase sequence.
一般如果我们的 SW 这个接触器，我们 SW 接触器向输出向去线接反了，可以不用去手动改线，可以通过参数来调整。
Usually, if our contactor, the phase sequence is reversal, we don't need to change, just to set the output order, the UVW, it can reversal.
然后下来有一个我们的 FF04，
And now we can see the FF04.
这是我们的一个变频器底座协议。
It is to check the bottom error protocol.
一般是与主板的我们的 F9需要保持一致的。
which generally matches the protocol code specified by the motherboard manufacturer.
如果我们的 F9是有协议的，但是 FF04显示0。
If the FF9 have protocol but the FF04 shows 0,
可以通过我们的 FF-11对一个协议进行自动重置。
we can use the FF11 to protocol reset.
重置之后，可以再次查看 FF04的协议是否与主板 F9一致。
After reset, we can check if the protocol is the same with the F equals 9.
然后我们的一个 FF07，
FF07 is used to extend inverter model.
是我们的一个扩展变频器型号，一般在要更新版本最低要在20.19。
But this requires the version at least at the 20.1 or 9. Okay, now let's see. If you want to check the description of the inverter model expansion, we actually need to require inverter. When the 0 equals 3-phase 380 volts, well, that is for the standard machine. Well, if you want to change to 3-phase 220 volts, we will set 1 equals converting 3-phase 380 volts.
然后下一个是我们的一个 F9。
Next part, let's see the FG.
密码是01320。
The record of the FG is 01320. Get into the FJ 杠
我
01.
们这里有一个 FG-36。
At this part, let's set the FJ to 36.
然后还有一个 FG-40。
And the FJ 40 bit 1 equals 1.
是我们加大一个输入缺项判断的阈值。
It's used to increase the input phase loss detection threshold.
FG-10 bit 4。
FJ 10 bit 4 equals 1 is used to disable the star blocking detection parameter. Simultaneously, F528 equals 0 and F5 equals 8 equals 0 must be modified.
我们这里的设置的这些都是通过我们的2进制去设置。
The site is all set according to our second.
比如我们的 FF-10设置的是03。
such as our FF10 set 03.
是通过我们的2进制1248、16、32以此类推的。
什么是2进制？
因为它通过2进制设计。
is 什么是2进制？没事。FJ10 bit 6 equals 1 is used to disable brake torque detection for all parameters.
然后我们呢还有一个 FG-10 bit 6。
Okay, let's see next part. FJ10 bit 6 equals 1.
F6-52 bit 10。
F6 52 bit 10 equals 1.
是关闭我们的一个爆炸力矩检测的参数。
Is used to disable brake torque detection for all parameters.
然后我们的 FG-08
FG08 bit
是屏蔽一
0
个37-406的故障。
equals 1 is to shinded E37406 fault.
然后我们这里有一些相关故障的一些参数。
And there are also about the other parameter.
F6-52的 bit 11
F652 bit 11 equals 1.
设置成1是关闭我们的 UCMP 功能。
When set it into 1 is to disable UCMP function.
相关的我们 F5-0 也要设置为0。
The relevant parameter is also required to change. F502 also need to set to 0.
然后我们的有一个 E21106 故障或者66故障。
When E21106 fault occurred, when E66 fault occurred,
我们进入 FG-10 bit 6设置为1。
at this part we need to enter FJ10 bit 6 equals 1.
然后 F6-52 bit 10也设置为1。
Also, F652 bit 10 equals 1 also.
然后21-107故障。
To access FJ group parameter, enter the 5-digit password 01320. And when entered to E21107 fault occurs,
FG-10 bit 4设为1。
set the FJ10 bit 4 equals 1.
F5-08 设为0。
I528 set to 0.
F5-28 设为0。
And F508 set also to 0 to enter the enter the 5-digit password 01320 into the FG parameter group to disable all parameter for star ceiling detection.
然后有一个是我们的一个主板继电器测试。
There are also a testing for our mainboard relay test.
进入我们的 F0-01 将它设为0。
Enter to F001, set it as 0.
然后在这里我们有一个
We-
F6
At this part, we have F6 to up on the keypad.
我们 up
And,
继电器测试。
yeah, and put it to up, which will enter into the relay test. After test completion, F001 set 1. 好有节奏呀。
我们把它 F0-01设为1，它就关闭了。
Set the F001 equals 1, it will close.
然后我们有一个软相位功能在 F6-40里边。
We also have the enable soft limit function at the F640 bit 1 equals 1.
将 bit 1设为1。
Set the bit 1 to 1.
bit 1设为就是开放我们的一个限位。
will open our soft limit function.
我们的 F6-41 bit 3是我们的一个校准通讯检修。
After at our F641 bit 3 enter the 1, it will get into the car top communication inspection.
然后我们的 F6-52 bit 1 F6-52 bit bit 1是我们的通讯型 SCB。
Our F652 bit 1 is our communication SCB.
这里分了两类 SCB。A 型的 SCB 需要 X2 需要设置参数。
The first one SCB need to set the
A 系列的 SCB
A series
X2
X2
F5-02
need to set the parameter.
然后如果我们用的 D 系列通讯型 SCB，
When use the D series universal SCB,
我们的门区信号在我们的x1 X1 和 X3 上。
our door signal is at to our X1 and X3.
我们的平衡信号将会在我们的校准通讯上。
Our level function will at our top inspection.
我们的 X2 就不用设 F5-02 要设成0。
The F502 need to set 0.
然后我们的 F6-52 bit 6是我们的一个看通讯平层。
F652 bit 6 is the functional to see the CAN communication level.
这个是我们校准如果有通讯平层的话，这个参数需要开通。
If the car top have the communication level, we need to open it.
我们的 F1-32 bit 2是在平层中的。
FE32 bit 2 is at the releveling function.
bit 3是我们的提前开门功能。
The bit 3 is our function of the early door opening.
这两个必须在有 SCB 版的情况下才能实现。
These two functions both need to realize when we have the SCB board.
然后还有一个 E37406故障。
There is also a fault like E37406 fault.
屏蔽参数在 FG-08 bit 10.1。
Is need to change FJ08 bit 0 equals 1 to mask the E37406 fault.
这个故障大部分需要调整我们的制动器。
This fault normally need to adjust our units.
我们的有一个通讯上平层和通讯下平层参数。
We will have a communication upper level and a communication lower level.
在 F5-25。
At the F525,
我们的 bit 9通讯上平层。
the bit 9 means communication upper level.
bit 10通讯下平层。
The bit 10 is at our communication lower level.
当出现了21-13故障时，
When occurred to E2113 occurs,
可以更改我们的 FG-36 bit 2等为1。
we can change the FJ36 bit 2 equals 1 to mask this fault.
下一个是我们的一个异步电机的一个开环检测。
Next is our astronomers machine open loop test maintenance run.
将 F0-00 改为1改为0。
change the F000 equals 1 to 0.
可以拔掉我们的 PG 卡检修运行。
Remove the PG card plug-in
同步电机不支持。
and perform maintenance run. It is not supported for synchronous machines.
如果我们的主板上面不会滚动故障代码，可以进入我们的 F642。
The motherboard fault will not score. Change F6 for 2 bit 9 equals 1 to 0 to restore normal display.
这样将1改成0，我们的主板就会正常显示故障代码。
Set the 1 to 0, it will normal display.
然后出现53杠105，可以做以下检测。
When fault 53105 occurred, we can do such the testing.
先取消掉我们的提前开门和再平层。
First, disable early door opening and releveling can reduce fault. FE32 bit 3 there equals 0 disabled early door opening. FE32 bit 2 there to 0 is to disable releveling. F611 bit 13 equals 1 enables E534 self reset. If car door force open, the system will attempt 3 door cycles. Persistence for feature triggers fault 53. Bit 14 equals 0 is disables safety door lock detection. Bit 15, FE32 bit 15 equals 0, disable door lock short circuit detection. F6 for 1 bit 12 equals 1 is to enable door delay before reopening. F538 there equals 0 and I539 equals 0, I540 equals 0 is to disable door lock high voltage detection.
然后我们如果使用我们的触摸屏，这样使用我们的触摸屏。
If the elevator car outlets a multimedia touchscreens connected to MOD communication,
我们可以去开通参数 F8-15 bit 4，设置为1，开通我们的触摸屏按钮。
to enable the touchscreen protocol, modify parameter F815 bit 4 to 1 to get a multimedia touchscreen connected to MOD communication.
然后我们的一个47-201故障，
Fault 47201 occurred.
在 F6-52 bit 1可以设为0。
Change the parameter F652 bit 1 to 0.
那下一个是我们的一些主板更换需要看的协议。
Now let's see about some mainboard change. We need to see which protocol.
然后我们如果是老的3000主板或者3000杠 B 的主板，
If it is the old 3000 or old 3000B mainboard,
所以我们的 FA-04是我们的辅助程序版本。
the FA04 is our auxiliary program version.
FA-05是主程序版本。
FA05 is the main program version.
FA-06是我们的变频器版本。
The FA06 is our inverter version.
我们 F5-33是一个通讯协议。
F533 is our communication protocol hall call, and FC05 is for our communication protocol hall call too.
FC-05也是一个外部的通讯协议。
说完了。
FB-01是我们的校准版本号。
FB01 is our car top board version number protocol number. 我把它读完了。1 is for Jiajie, 2 is for Senhe, 3 is for Shandong Beast 121, 4 is for Dio, 5 is for Honda, 6 is for Deao. Early product reference F533 for protocol, while later model use 5C05. Note both parameters.
如果是我们的新主板 NICE3000new 的，就 MCTC、MCB-C 的主板，
If it is our NICE3000 new version board like our MCTC, MTB, C1 or 2.
就看我们的 FP-07 我们的校准协议。
FP07 is to see our car-top protocol, FP08 hall call protocol, FP09 manufacturer protocol. Press F9 on the keypad to switch to 1 for real hall call and manufacturer protocols. FP01 is for our car-top software.
如果看不到我们的 FP07、08、09，
If cannot see the FP07, 08, and 09,
需要检查一下 FP-00、FP-03、FP-04是否被设置密码。
we need to set if the decode is set for the FP00, FP03, and FP04. Right. Okay. Okay, now let's to our last part, troubleshooting peculiar elevator fault. First, we will answer typical question from chat. And our friend who participates in today's chat room interaction, please contact us via our email or WhatsApp after the live broadcast to claim your small gift. Due to the time constraint, this training is now come to close. Thank you all for your active participation. After the live stream end, feel free to reach out to us via email or WhatsApp. We'd be happy to answer any question you may have. Oncoming technical training will feature KONE and Schindler elevators. Remember to subscribe to our YouTube channel to get notification in advance. See you soon, everyone. Okay, if you have any question, we can get some communication in our chat room. Now you can give some question from our chat. We can see one question from the can we replace Otis ACD5 controller? 我们能更换奥迪斯 ACD5 的控制柜吗？
要更换成什么的？
What do you want to change to? And could it be possible to replace Otis ACD5 WC9 drive? 他说有没有可能更换这个奥迪斯 ACD5 到这个 WC9 drive？
驱动器。
有吗 ？drive？
它只是更换变频器呢。
Only change the inverter or the whole controller cabinet. You can give the answer at the chat room. NICE1000 how can crack? 这是之前的要答吗？已经回答了。OK。那现在这个问题就是有没有可能更换这个奥迪斯 ACD5 这个 WC9 drive？
它是用什么？是原来奥迪斯的，还是说用其他系统去更改这个？
更改成这个还是说？ We want to get best option to replace ACD5 drive of Otis elevator. 他们想有一个最好的方案去替代这个 ACD5驱动器给这个奥迪赛电梯。
可以啊，可以让他联系我们的邮箱。
This sir, you can connect with our email or our WhatsApp. Our at the screen we put our email address. You can have a check and send the email request to our email. Thanks so much. With 他也是，我也看到他说 WC with Monarch system。我觉得他的意思应该就是说，他原来的电梯是奥迪斯电梯，然后 ACD5 drive，他现在想用莫纳克的系统去更换。
没问题。
No problem. If you want to change with the Monarch system to replace the ACD5 drive of Otis elevator, this is no problem. You can just contact our email address or our WhatsApp. We will have the personnel to contact you later. 这个 Tracy 陈是谁？玲玲。If there have any other question, if there is any other question, if there is no, we will say goodbye for today's training. 人人给他的回答吧，应该是 check the connect cable of the inverter。今天有车长行业吗？那我就结束了啊，那我就说也没问题了嘛，是吧 ？OK。If no problem, we will have to say goodbye for today. Upcoming technical training with feature KONE and Schindler elevator. Remember to subscribe to our YouTube channel to get notification in advance. See you soon, everyone.
Bye.
Bye bye.
那网卡的有点多了。
还没结束吗？